Alright, in this video we're going to see what kind of a focal point we get with a concave mirror. Let's just review. The definition of a focal point is the place where parallel rays intersect. Or converge is a word we like in optics. Parallel rays, and by parallel I mean to the optic axis. And remember here the optic axis goes through the middle of the mirror. So, if we had a mirror, concave, so it's caving in like this, and we drew and we imagine that mirror is a giant circle, then the center of that circle would be somewhere like here. So that's called, see, the center of curvature. So you can see that if that was a giant circle, like then this represents the center of that circle. So if we're looking at this curved mirror, we call that the center of curvature. And the optic axis is the line that goes straight through the center of the mirror. So that means that it's going to go through the center of curvature and the middle of the mirror. So something like this. So that's our optic axis. OA is how we label them. And then if we want to know where our focal point is, we're going to see what would happen if we brought in multiple parallel lines. I'm going to bring in that one. I'm just going to bring in two for now. And then if you look at it, we could do this with more, but we'll just start with two because more than that in this diagram is going to get really busy and a little bit confusing. So let's zoom in on this part right here. Okay? So for what I'm going to draw, we're going to assume that's that circle. So we have this part of the mirror right here, and we have our ray coming in. Now if we imagine, remembering our law of reflection, that the normal to this mirror means at 90 degrees to the mirror, then it would be something like that. It would be a line adjoining the center of curvature to that point. That makes 90 degrees with the mirror. And what we know from our law of reflection is that the angle of the incident ray is going to be equal to the angle of the reflected ray. So the reflected ray is going to come out something like this. Theta I equals theta R. That's our law of reflection. So it's not perfect, but what we know is that the reflected ray is going to come away something like that. Okay? Now let's do the same discussion, but let's look at this circle right here. So I'll call this A, and then I'll label this A so we remember. And then I'll call this B, and then I'll label this one B so we can keep them straight. At this part of the mirror, something like that, the normal going to the center of curvature looks something like that. So when this ray comes in, the reflected ray, according to the law of reflection where theta I is equal to theta R, is going to reflect somewhere like that. Now to put that on the big diagram, what that means is that it's going to reflect something like that, where this angle and this angle are the same, and this angle and this angle are the same. Now what's interesting about that is we notice that we end up with this common point where those two parallel rays came in and reflected through the same spot on the optic axis. That point is called the focal point. And just from observation with our mirror, we can see it is about halfway between the mirror and the center of curvature. Curvature, I don't know how to spell it. Anyway, so that is how we find the focal point, the place where parallel rays intersect or converge when they bounce off a concave mirror. I could add a whole number of other parallel rays in this diagram. I could keep doing the same thing, and what I would discover is that they would all go through that. Oh, let's try that again. They would all go through that same point. Let's see if this will work now. I don't know why I'm not getting a straight line, but anyway. So, no matter which one I came in at, they would all reflect up through that same point. So that's the definition of a focal point. For a concave mirror, they have focal points that are in front of the mirror, and they're about halfway in between the center of curvature and the mirror itself.